hello and welcome to our next and final webinar this year, 2015, with the topic New IP Devices, IP Router and IP Interface, Part 2. So we do not repeat the webinar from the last month, but we will add some hopefully interesting things to this webinar we have done the last month. Let's have a look to the agenda first of all, what is planned for today. Topic IP Router, IPRS 311 and IP Interface, IPSS 311, the new components which are already launched, so available. I will summarize the main features at the beginning, but very short only, what we have done already in the last webinar. Then we got some feedback regarding wording, tunneling, routing, unicast and multicast. What is really behind? Kind of definition, general explanation I would like to give to you. Followed by the topic how to assign IP addresses to these devices. There are different options we support with our components, also here a bit more detailed explanation. Yeah, then we will go to some details of the ETS parameters of the IP router, followed by the ABB IBAS tool, where we will go also in some more details, especially together with the option Unicast mode. How to adjust this in the IBAS tool I will show to you. And then Jürgen will follow with the topic ETS routing with visualization, and the same for tunneling. How to adjust it, some more details in this regard. And remote access to KNX is always a topic. VPN, virtual private network, is here a kind of keyword we would like to explain a bit. And last but not least, we talk about how to visualize network telegrams, what you can read out of these telegrams. When is it interesting or necessary to check this on the network side? Good, let's start. First of all, a summary of the main features of our new devices. IP interface I would like to start. We have these 5 tunneling servers now available, so 5 tunneling connections at the same time can be established via the IP interface. I come to this later on a bit more detailed. Again, important is that with ETS3, you can still use ETS3, only 1 tunnel connection is available. It's a limitation in the ETS3. Yeah, power supply, we need additional power supply as before. 2 options, a DC voltage between 12 and 30 volt is possible, so with any external power supply, or power over Ethernet, a new option. Can be used if you, in accordance with this class here, IEE 802.3AF class 1, then you can use also power over Ethernet to supply the component. There sometimes comes a question up why we have to use any external power supply. The very powerful processor inside this device needs more current we can take directly from the KNX bus, so it's not possible, and that's the reason why we need here external power supply. Yeah, the hardware has been adapted. Remember, we have this adapted network connection here to have more space for the cabling, for the wiring in the distribution board. The labeling field have been improved. The DIN rail connection, especially to release as a component, it's now possible without using any screwdriver. The cover cap covering the KNX bus and also the low voltage power supply connection, so makes a safe insulation between any 230 volt wire going in parallel here and these connections. And the programming button, not visible here, has been adapted a bit. It's now easily to use a screwdriver, but also your fingernail is still possible to press a button. Yeah, LAN connection as before, we can connect 10 or 100 megabit networks, the speed, and I come to this in more details later, the IBAS tool support, of course, as in all new devices, also available for the IP interface. Yeah, IP router. This is the same like the IP interface at the beginning, tunneling server 5, power supply and the adapted hardware. But we have some differences compared with the IP interface. First of all, this unicast communication as a specialty in ABB IP router is available. I will explain how it works in the IBAS tool, how to adjust this. Standard network communication, KNX Net IP protocol, is multicast, so-called. I will explain this also in the next slides. but if you have a special situation, you can use also Unicast with up to 10 IP router. Yeah, then our new IP router supports the so-called network management function. If there's any KNX bus voltage failure, then directly from this IP router, IP telegram can be sent on the network informing about this malfunction to any, for example, visualization, and then you have clear feedback that something is wrong in the line behind. Yeah, then additionally we have this full support of this extended range of group addresses. Remember, starting from ETS4, the group address range has been extended, more or less duplicated, so around 65,000 group addresses are now available. Up to now it was not possible to filter this extended group address range. Only the standard group addresses we have used already before, but now also the IP router supports complete filtering of all group addresses, like our existing line coupler LKS 4.2, the same situation now. Yeah, IBAS 2 support, also here, I will show it to you later on. I mentioned already the powerful hardware, which needs external energy, so we have also enhanced the hardware, and network connection or network speed, 10 or 100 megabit communication is supported here. Yeah, let's come to this wording. So these items I would like to explain a bit. I've just mentioned standard communication is multicast communication on the net, on the IP side with our IP router. What does it mean, multicast? Multicast designates communication of a transmitter with a group of receiver, point to multipoint. You see it here in this picture. Of course, in our case, the IP router or IP interface are the components. But here you see one IP router can communicate with other IP router. Of course, that's what we want to do. And in principle, the IP router sends the KNX telegrams packed in UDP, IP telegrams on the network, and all IP router parameterized with the same multicast address receive and evaluate these telegrams. So there's another important topic, multicast address. I come to this later. All IP router with the same common multicast address can communicate with each other. But multicast in principle means from one transmitter to multiple receiver. Of course, vice versa as well, not shown here. Also a component here like this can send to the transmitter something. So it's a group which can work together. So point to multipoint and vice versa. Unicast refers to the communication between one transmitter and one receiver normally. So on the left side on this picture you see one transmitter sends to any recipient. This would be unicast communication. Also in the other direction in principle possible. In our case, in the KNX world, together with our IP router, we have this unicast communication possible, but not only like this. Also grouping, unicast groups are possible. We will see later on. So one IP router can send to selected other IP router, maybe not to all, but to selected ones. So this is a kind of unicast group. In principle, we will see it later, it's linked via the IP address of each device. Yeah, then this keyword tunneling, what does it mean? Tunneling, if you have a look to the traditional or classical definition, tunneling means in an IP communication the transfer of data from one protocol to another protocol with no change of the content. In our KNX world, if we create a tunnel connection through an IP interface or IP router, both can do this, we send from KNXNet IP, telegram via the tunnel, via the component, translated to a KNX TP telegram directly through. We translate it, but we don't change anything in the content. So in our case, data can be sent via the tunnel as a KNX telegram on twisted pair from network and vice versa in both directions without any evaluation. So no filtering, no change in the content will take place here. That's a tunnel connection. And remember, our new components support now 5 tunnels in parallel. That's possible. Yeah, if we look at a bit more detailed here in a KNX system, for example, you see here the network. connected to any IP router, IP interface, our new ones of course, and behind we have our twisted pair world with different devices. And on the LAN side, on the network side, different applications are connected. For example, PC with the ETS, a visualization, or our IBAS tool is a further application, or any tablet PC via Wi-Fi connected to the network here. And all these applications, up to 5, can work via a tunnel connection through our IP interface, IP router, to the real components behind in the twisted pair world. You see, each tunnel connection gets also an individual address, additional individual address, and showing you here that you have an individual tunnel available. And last but not least, routing. What does it mean? The definition is like this. Routing for data in a network means a description for a telegram how to find the way to the receiver. So it's a kind of guide necessary, which tells the telegrams where to go, in other words. So in our case, the multicast address, already mentioned before, I come to some more details later, or the membership in a Unicast group, which is a special situation, also later on explained, is the criteria and the guide for this. On the KNX side, finally, the filter table. IP router have, like line coupler, of course, also filter table available, completes the process for the telegram to be sent to the right recipient. So a telegram coming in routing mode to the IP router will be evaluated. Is it the same multicast address, a correct multicast address, or does it belong to the Unicast group, if this is adjusted? And last but not least, is it member of the filter table? And then it will be sent out down to the line behind. So it's a real, let me say, it's a guide to help the telegram to find its way in this complete network, for example. And have a look to a more KNX related picture here. Constellation with 4 IP routers, 4 lines behind, you see it here. Of course connected via network. And you can see here, we have written here to each IP router this so-called multicast address, 224.0.23.12, which is a defined multicast address for KNX communication on the KNX NetIP protocol. So let's take an example. If a sensor in this line send an off command to the IP router first of all checks in the filter table, is it necessary to be sent out? If it exists in any other line, then it's part of the filter table. Will be sent out as a KNX NetIP telegram. Not only the group address, but also the multicast address will be added to this telegram. Sent on the IP network. And all other KNX IP components with the same multicast address, like these here, will receive the telegram. But only in this line, 7.2, this group address is also part of the filter table. There the filter table, or the gate will be opened and the telegram will be sent to the dedicated actuator. Other IP devices like a PC or a network attached storage or a printer for sure have not the same multicast address if they are listening to multicast telegrams, and they don't take care of these telegrams coming from the KNX components. If you want, you can do the following. You can change a multicast address also in an IP router. Here an example, IP router still existing but with a different multicast address, 80. What happens with the telegram? Though you have here an actuator which needs this telegram, 2336, telegram will be received here, but with a different multicast address, 12, IPRS will block this on the IP side already. So it will not be transferred and not evaluated via the filter table. This option you have, specialty but possible, though we use normally this standard KNX NetIP multicast address which is defined 224.0.23 and 12. So reserved for KNX and normally used in all KNX IP devices to be able to communicate with each other. Finally, here an overview to differentiate IP interface and IP router. There are also sometimes confusions. People sometimes mix something up, so we try to find here or to show you here a short overview of the different functions supported by these devices. Coupling, replacement of line and area coupler, only possible with the IP router, working as a line or area coupler with the communications I have mentioned already, typically in multicast mode. Not possible with the IP interface. So absolutely not possible, and you cannot replace a line and area coupler. Using IP router or IP interface for downloading via ETS, connecting a visualization, or if you have Wi-Fi, an app on a tablet, is easily possible and supported by both devices. The routing function, more details also shown later. In principle, also possible only with the IP router. That has to do with line and area coupler replacement, so not possible with the IP interface. But the tunneling connection, already mentioned, 5 tunnels are available in parallel, available for both devices. So you see the whole performance only available with the IP router, but in some cases, of course, like here, tunneling connection or interface usage, IP interface is absolutely sufficient. Yeah, another feedback we got from the last webinar, we have mentioned here the last webinar already, this DHCP server, or this assignment of IP addresses via DHCP server or auto IP addressing. What does it mean? Let's have a look to some more details of this wording. Our IP devices support both DHCP and auto IP, but also you will see later on fixed IP. If you have a so-called DHCP server in your IP network, then a new IP device gets automatically the next free IP address, which is available in the network. So you don't have to take care of anything, it's automatically done. If you don't need a fixed IP address, you can go this way. Prerequisite is you have a DHCP server in your network, of course supported by our components. Assumed you have adjusted this, but no DHCP server were found due to any reason, not running at the moment, then a so-called auto IP procedure will be started, and an IP address to our IP devices in this range 169.254.xxyy will be assigned. Remember, IP router, IP interface is always an IP device as well, so it needs the IP address. Otherwise it cannot work in a network. So, assumed a bit later the DHCP server comes up, starts up again, then via the DHCP server a fitting IP address will be also later on then assigned. So this auto IP is only a kind of special case. A DHCP server will then take over and assign also the correct IP address. If you have to restart the device or you download again application, then the IP address is lost, and again this procedure will start. DHCP server normally, or if not available, auto IP will start. So in both cases, in principle, you don't have to take care of the IP address. Assignment will be done automatically, typically, of course, via this DHCP server in a real installation. If you would like to add or assign a fixed IP address, in some networks necessary, you get maybe in a network a range of IP addresses for your IP router, and you have to use these, nothing else. Then we can change in the parameters, go to fixed IP address, and you type in, we will see it later, directly the IP address with subnet mask and default gateway. So then it will be never changed, and you have assigned a fixed IP address. Later on we will see it is important for the Unicast communication, because here the IP addresses have to be known, and if any change happens, it will, let me say, will be a problem. Okay, I get your feedback here that the connection is lost. Jürgen, anything okay? No, Jürgen gives me a feedback. Should be okay. So one participant tells me here lost connection. Okay. Good. Yeah, let's come to some more details of the ETS parameter, of the IP router at least, because there are real parameters available you can adjust. The IP interface is nothing available in this regard, so no group objects and no parameters. So what is available? First of all, we can parameterize here what shall happen with our group addresses, filtering, routing or blocking. As before, new is that we can also filter now this extended range of group addresses up to main group 31. So that's new. And then with our physically addressed or broadcast telegrams, I will explain in the next slide what is behind these telegrams. We can decide filtering, routing or blocking. So we can really, let me say, influence what shall happen with dedicated telegrams on the bus. Interesting is downloading an application or downloading a physical address. You can block this if you want. We will see. And in case of any confirmation you need, telegram confirmation, you can adjust also something here. A group telegram normally will be confirmed or acknowledged by the IP router. You can decide only if routed, or in special cases always. Can reduce traffic if you have, for example, the filter table deactivated, and in special cases you can adjust something here. Yeah, and these broadcast and physically addressed telegrams, I would like to explain here a bit. What are physically addressed telegrams? A lot. Download application, everybody is doing continuously, is a physically addressed telegram. And the other options here, to check an individual address, is it existing in an installation, you would like to read out a device info, you would like to activate the LED, programming LED of your KNX device, and so on. These are all, let me say, diagnostic functions in the ETS. Yeah? If you want, you can block this. Broadcast telegrams are less, but one important broadcast telegram, everybody knows, downloading the individual address, the physical address. Yeah? And by using the broadcast telegram, a group address 000 will be sent, which is a group address you cannot use for any other purpose. And this runs or goes over all coupler and allows you to send to any, let me say, part of your installation. Downloading individual address, but also checking is any device in programming mode. Also an ETS diagnostic function can be done here. So again, you have options here to influence any communications in this regard. So not only from KNX to LAN you can change this or influence this, but also from LAN to KNX. It's the same principle here we have discussed already. The only thing you can additionally adjust here in case of any errors, so communication errors, you can decide what to do with a telegram. Yeah. You can go to individual or user-defined adjustments and then decide again what shall happen with your not only broadcast and physically addressed telegrams, but also with your group telegrams. In principle, repeat it yes or no. Good. IP settings, very simple. I discussed already with you a bit. We can change between multicast and unicast. Typically multicast, but unicast, I come to this later. So it's only a parameter here. And on the right side, you might remember from our last webinar, we have two additional functions here, blocks, settings and IP. And if you click on IP, you can decide what to do with the IP address. Remember, obtain an IP address automatically, DHCP auto IP, or fixed IP address. And if you say fixed, you can type in here the dedicated values. Yeah, and settings, sorry, no, group objects are not existing here, so we cannot have to assign any group addresses, not necessary here. Yeah, furthermore, on settings, you see here the option to write down a name to the component you have chosen here, the IP router. We will see later on in the IBAS tool, it makes really sense to give a name here, because if you have numerous IP router in your installation, it makes sense to distinguish it between a name or via a name, and this should be done here. So any application download then assigns this written name to this component here. Yeah, and now I would like to show you some more details from the IBAS tool. As all new components, we support the IBAS tool also here, and I would like to show you what you can do here. So first of all, we talk about IP devices. If we talk about the IP router and the IP interface, so from the IBAS tool point of view, we have to go here on IP device. If you open the software, not connected to device, but you click on IP device. So if your PC is connected via Ethernet to your network, and behind there you find any IP devices like IP router, IP interface, then if you click here on IP devices, you should see all connected IP devices, KNX IP devices, in this window here, in this screen. In this case, automatically 3 IP router are detected, with some data. And here you see the name we have given before via the application download, physical or individual address, IP address, MAC address, okay, it's a hardware address, and I come to this as well, firmware update or firmware status. We have some options here in the IBAS tool to adapt or to update the firmware. Furthermore, you find here some more detailed information. Depending on the selection here, you click here on this device, it will be marked here, and then you get some detailed data of this component. So the firmware version, also IP address here, the speed of the network, routing multicast address, remember the fixed IP, routing multicast address you have for KNX world reserved. So you get a lot of information to the device, and can easily identify now components. If you don't see any KNX IP components, which are normally should be seen because you have connected everything is working fine, then this information or this message might come up. The device have been no device have been discovered. No devices have been discovered. If you think some should be detected, consider adding firewall rules. What does it mean? Most probably, your virus scanner has a firewall active and does not allow you to get connection via IP to the components. So it's blocked, the communication. So in this example here in our ABB laptops, we have this McAfee virus scanner. And if you click here on this device, right mouse button, quick settings, then you find the status of the firewall, in this case on. And then you have to switch it off. So this is necessary sometimes, depending on the situation, and keep this in mind. If you have a network scanner, Jürgen will come to this later, you would see all these IP addresses, also maybe from this IP router, but not on your IBAS tool. Then it's a typical situation that something is blocked here. Yeah, I mentioned already that we have an option here in the IBAS tool to update the firmware if necessary. Don't worry, it's not daily business. We don't expect it in the near future, but maybe it's necessary to give you a new firmware for the IP router, IP interface. Then you can easily update the firmware by means of the IBAS tool. What do you do if you start your IBAS tool? We have here this button at the beginning, not visible here, but check update. There are 2 buttons normally, check update and connect. You click here on check update, and you come to this screen here, and then you click on IP firmware update. And then, if exists, it will connect to our server. It will show you a new new firmware version for our IP devices. You can download this from here, and it will be stored in the IBAS directory on your PC. So it will be downloaded directly, and then if a new version is in your directory, in your folder of your IBAS tool software, it will display here with a this yellow marker. There is a new firmware existing. The only thing you have to do, you select your device, go here to update, and start the update mode or the update process by clicking here on this green arrow. So select device, update, start, and then something else might happen depending on your local situation. If you have no administration rights on your PC, then this window will come up. informing you that you have not the whole rights to start this update. What do you have to do? You have to start your IBAS tool again, but not directly by clicking twice with the left mouse button, but with the right mouse button, and then you have the option Run as administrator. Do this, and then you can start also this firmware update. So this could happen as well. So if you are succeeding, this window will come up after you started the firmware update. Here now you can choose the firmware version. Maybe there are some more in your folder, older versions as well. And you select the newest one here. And finally, really, you start here. And with the slider here, the progress slider, you will see the process of updating your firmware of your IP device. So if necessary, easily possible, we support this here. Yeah, further options you have in the IBAS tool together with the IP devices. The button Blink LED allows you to identify one of your numerous IP devices which might be connected. So you click on the device you would like to identify, this one, Blink LED, and then the On LED. The LED on top of our IP devices start blinking sometimes, I think 5 times. But also shown here in this activity column that obviously the LED is blinking. And then you know, okay, this is my component here with this individual address and IP router and so on. And finally, you can also restart a component by clicking on, first of all, of course, you select always a device, and by clicking on restart, the component will be restarted like in the power failure situation, like disconnecting the power, for example. So some easily diagnostic and detection options you have here. Let's finally come, at least from my side, to the Unicast communication we can adjust here. Also in the IBAS tool, the specialty ABB offers only. So again, normally we have this multicast communication. KNX Net IP protocol means multicast communication, standard. If in your network, your IP network, it's not allowed to have multicast communication because it means a bit more traffic. For example, your IP router are connected to the network in the building, which is also used for other purposes, for other communications. Then the network administrator should be involved, and he maybe refuses any multicast communication. That happened in the past, very seldom, but it happened. Then we can offer an option by using the Unicast mode. And Unicast means that I, in principle, assign to KNX IP devices selected other IP devices to be communicated with. And I do this via the IP address. So in this example here, we have 3 IP router. Each has an individual IP address, the blue one here. In addition, we have any PC with a visualization, which of course is also an IP device. We would like to assign also to our KNX communication. So what do? You create Unicast groups, and in the groups you say which other IP addresses should work together with this IP router. For example, this IP router 12 can work with 36, is this IP router here, can work with 47, is a PC, visualization PC, and can work with 88, the other IP router. So create individual groups where you have kind of Unicast groups. That's possible, and I will show you in the next slides how to do this. Important is, or different from the multicast communication, is that we have acknowledged data exchange. That's also an advantage. In the multicast communication, we have unacknowledged communication on the network. So you send once the command on the network, but it's never acknowledged. Here we have acknowledged, which is in further, let me say, advantage of the solution. And you have less traffic. But again, it's a specialty, not in compliance with the KNX standard, KNX Net IP protocol, which is normally multicast. So maximum 10 devices can be linked with each other. So how to do this? Before we come to this in the IBAS tool, I think more or less a summary, what I have mentioned already. We do it with the IBAS tool. In total 10 devices can be linked with each other. Yeah, important is, I already mentioned by myself already, you need fixed IP addresses. Otherwise, you might get problems due to any assignment of new IP addresses to IP router. Then, of course, your system does not work anymore because you have to rely on fixed IP addresses to get connection to these devices. Yeah, let's come to this adjustment finally. Okay, in the ETS, very simple. You just only hear Unicast, download the application, and then it will work from the ETS side at least. But you have to create these Unicast groups. How to do? Back to our IBAS tool. You go now here to Unicast. You see here is a further option, Unicast. So we have our 3 IP router as before. We go to Unicast configuration. You see again your IP router. And here's a further button now, create Unicast group. You click on this. But before you do this, you select the IP router you would like to assign to the Unicast group. Maybe not all 3 should be a Unicast group, maybe only 2. But in this case, all 3 are selected. And I create for these 3 a common Unicast group by clicking here. Then you give a name to this group you would like to create. And you confirm this, and then normally a confirmation will come up with information that all 3 IP router are member of this Unicast group. So very simple to assign Unicast groups. Yeah, if you have done this, you will see immediately at all 3 IP router information about their membership to Unicast groups. In this case, Unigroup Alpha is the name of this group. All 3 are members. And you see here also, if you click here on Unicast configuration, it's a further option, not detailed data, but Unicast configuration. Yeah, belongs to this. Okay, I've selected here this IP router. And if I click here Unicast configuration, you see here the other 2 IP addresses which are member in this Unicast group. You can see it here directly. 88 and 12. These both devices, yes. Okay. So that's the creation of a Unicast group. If you click here, Group Device, then another window appears here, again, with the 3 IP addresses which are the member. What can you do here? First of all, you can delete also here by clicking on this cross, if you would like to remove this again from the group. But more interesting is to do the following. You can add also additional IP addresses here by clicking on this plus button. Then a new line appears here. We can type in a further IP address, for example, from your PC, visualization PC, which you would like to add to this Unicast group as well. Because this is not detected via the IBAS tool. It's an external device. You have to add it here manually via the IP address. Yeah, and if you confirm this, it confirms, okay, the other 3 IP routers in this case are a member of this group as well. But again, if you click here on one device of this Unicast group, you find all other network addresses which are member. So not only the IP router you see here, but also our PC with this IP address. Marked again with this yellow sign here, showing you that any external device is now a member of this Unicast group. Here on top are 2 other buttons I did not explain up to now. It's easy also possible to remove here in this view any member of the Unicast group by clicking on one device and clicking on this red button or red cross. You will remove this one here from this Unicast group. Or if you would like to extend, you can click on a non-selected IP router not visible here and can extend this in this group. So it's easily also here to change something in the group. Okay, I would stop here because it's a bit special, the Unicast mode, but available. Keep it in mind, easy to handle, and KNX ABB component IP router is supporting this. Good, I would stop here. hand over to Jürgen. Jürgen is coming now with some more details. Just a moment.
Hello and welcome to the second part of this webinar. My name is Jürgen Schilder and I'm showing you now how you can use a routing or tunneling connection to make a download, how to connect the visualization system, or for example how to make a download from outside the building via VPN and to have access, for example, also via a tablet. So I would like to start with a so-called routing connection. So the IP router can be used as a default for coupling different lines or areas, but additionally we can use also the IP router to make a download via the ETS. So now when we use the routing mode, it is very important that our our telegrams are here on the IP network. It means that our local interfaces of the ETS or our visualization panel, for example, must have addresses here out of our lines or our areas. That's why it is recommended to use here as the local address of our ETS, for example, 00251, for example. So here, for example, our IP router with the address 130, and all devices here have addresses 1326 and so on. Good, then let's start with such a routing connection to make a download. We create here a routing connection. In the next slide I show you how we can do it. So we go to the ETS, create a new routing connection, we select this routing connection, and then for example we download a device with the individual address 1124. So what happens? These telegrams are now packed in this so-called multicast telegrams, goes here on our IP network. The telegrams goes here on the left side, goes on the right side, goes down here to this IP router. This IP router is looking here, for example, at the multicast address. Yes, it's for me. Then he forwarded it here also depending on the physically addressed here into the line, and the device receives the download. So additionally, the telegram goes here to this IP router. He checks the multicast address, said yes, this is the correct KNX multicast address, but the address, the topology here is not correct, and then he blocks the download. And so on. The telegram goes to this IP router, goes to this network. So we have this download when we use the routing connection in our complete IP network. So we are locally with our ETS, maybe here on our IP network. And some network administrator don't like so much traffic. But this is maybe, I think, the disadvantage here of our routing connection. But in principle, we have the download here in our complete IP network. So how to create such a routing connection? It's very easy. We go to the ETS, to the menu here, bus, and then we can see here all our interfaces, our, for example, configured interfaces, or here also the so-called discovered interfaces. And here we can see the network adapter of my laptop. So here it looks here, this green icon like a network adapter. Maybe here, for example, the Intel Ethernet. This is the description of my network adapter. So we click here on this network adapter. You can see here it looks like a network card, and press on the right bottom here this button select. And then this network adapter is selected for this routing connection. When you have enabled the Wi-Fi connection, then you can see a second network adapter for your Wi-Fi connection. But in principle, one PC like here, this one, we can create only one routing connection. Independent how many IP routers we have in installation, we create one routing connection. And here on the right side you can see again the so-called multicast address 224.0.23.12. So do not change this multicast address. When you change it, the download maybe will get some problems or is not possible. So the next step, we press here the mouse, this field here, address free. Before we have to set here the correct local address of our routing connection. And remember, the address must be out of the topology of our KNX installation. That's why it's recommended to use, for example, here 255 or 250. Click on the button, address free, and then we get here the feedback. Yes, the individual address is free, and we can click here the test button, and then we see the result. Yes, the communication is okay. So afterwards we can start making the download. We can download the individual addresses of KNX devices. We can download the application. We can start a group monitor. We can do nearly the same like we have connection via USB. Good. So far the routing with ETS And when we have in our KNX installation a visualization system or a panel, for example, then we can do nearly the same steps. Very important that the routing connection in our visualization or panel needs also an individual address, the local address of the interface, which is here outside of the topology. Yeah, so for example here 00255. So we go to the software of our visualization system. For the interfaces, then we have, for example, here also the menu KNX Net IP routing. We can select here or type in the correct multicast address, the port, and here our local address programming interface, which is 00, for example, 255, and click on the button OK. And then the visualization, or for example here the panel, uses here this routing connection. So, but be careful. Routing means that the visualization is looking here or listen to the KNX Net IP telegrams here on our network system. Yeah, the visualization is not listen what happens in the lines. It listen here onto here to the KNX Net IP telegrams. So very important. For example, we have here one sensor in this line, which sends the group address 14192. In this line, we have an actuator which is listening to this group address 14192. What happens? The filter this group address is written automatically here to the filter table of this IP router and this IP router, which is absolutely correct. So when we press here this rocker number 1, he sends the group address to the IP router. The IP router receives the group address. He looks in the filter table, said, yes, I know this address. And then he packed it into a KNX Net IP telegram and sent this telegram here to our IP network, to this IP router. The IP router receives this telegram. He knows, okay, the same multicast address. He looks in the filter table and then he forwarded the telegram into the line and the actuator switch on or switch off. Parallel, the visualization system, which uses also the routing connection, listening to the telegram and shows here the correct status of this switch actuator on or off. So everything is fine. But what happens when we have a sensor like this one here with this group address 2336 and the actuator in the same line? So this group address is not used in another line. So this group address is not added to the filter table, but we want to see the status here on the visualization or on our panel. So now when we press here this rocker, the group address goes here down to the actuator, he switched on, goes to the IP router, but the IP router said, okay, I don't know this group address, and then the telegram will stop here. So our visualization system, we cannot see the correct status of our group address 2336. Because visualization uses the routing and here there is no telegram. So what can we do to solve this problem? We have different solutions. For example, one is we change the filter table of our IP router. Default, for example, is that we use the filter table, but we have also one parameter route. Route means all telegrams we have here in this line are now forwarded into our IP line and also in the other direction. And then this principle works. We press here the rocker 2336, the group address goes to the IP router. All group address telegrams are forwarded to the IP network. This actuator switches, the group address goes here to the visualization. We can see the correct status, or we can also send commands here into the line. But the group address goes also this way, goes here to the IP router, which has also the parameter route, and then he forwarded also this group address here into this line. But there is no device which is listening to the group address 2336. What happens? No acknowledge, and then he will repeat this telegram up to 3 times. So we have here high bus traffic. So I think this is not the best solution, because we will have a lot of bus traffic in our KNX lines. Because the same happens here. When he sends the telegram to the IP router, to the visualization, and the telegram goes also here in this line and will be also repeated 3 times. So we have here really a high load of bus traffic. So I don't recommend to use this principle. A better solution is to install a so-called dummy device. Maybe you know this principle also from our line couplers. Then we have, because we face there the same situation. So in the ETS, we create another area, for example, area number 15. We insert an IP router and a KNX device. But this is only in our ETS. It is not in reality installed. And then we link the group address of the sensor here to our here to our device, and additionally we link the group address to the KNX device here in our area 15. So the ETS believes, oh, there is a device, and then the ETS added this group address automatically to the filter table, to this IP router. So after the download, when we press here this rocker, he receives the telegram and forwarded it here to our IP network, and our visualization or panel shows the correct status. He receives also the telegram, but he said, okay, I don't know this group address, and blocks here the telegram. So I think this is one of the best solutions to go to the ETS and add here a so-called dummy device, which exists only in the ETS to simulate maybe that the group addresses must be added here to the filter table. But what can it be, such a dummy device? Like, for example, you can use a switch actuator, you can other KNX devices, but I recommend to use, for example, an ABL. So now go to the topology, create area number 15, a new line, add here, for example, the IP router and an ABL, the ABL, the application unit logic. Open the parameters. You can write here a small comment in the parameters of the ABL. Insert here some inputs, and 1-bit input, 1-byte input, 2-byte input, 4-byte input, and that's all. You have not to link here group addresses. You can create only here the different sizes of sizes of the inputs. And go back to the ETS, and then we get here, for example, our different objects: 1-bit, 1-byte, 2-byte, 4-byte, and then we link here the group address of our sensor to this device, and then this group address is also automatically added to the filter table of our needed IP routers. So this is one possibility to use an ABL, or can also use, for example, a control panel or other devices like you want. So now let's come to the so-called tunneling connection, which works a little bit different. So the IP router can use up to 5, or has up to 5 tunneling connections at the same time. What does it mean? We have here our PC with the ETS, and then we create a tunneling connection here into our KNX line. So very important, a tunneling connection must have the same local address like a device which is really here installed inside the line. So we make really a tunnel from here to there, like the PC or the ETS is connected here into our line. Also, when we later create a tunneling connection from our visualization, then it's also very important that a tunneling connection of the visualization must have also an address like the visualization PC is really connected here to our twisted pair line. So, or our IBAS tool or the tablet, we can use also different kind of tunneling connections. Maximum 5 tunneling connections we can have at the same time. So then let's start. We have here different IP routers, maybe 5, 10 or 100, doesn't matter. Then we go here to our ETS and we create such a kind of tunneling connection. So tunneling from this from our ETS here into the line 13, and then remember the local address of this tunneling connection must be 13, for example 251. To the next IP router we have to create another tunneling connection, and here the local address of this tunneling connection must be 15,255,51, for example, because here this is the IP router 150. And this IP router has the address 270. We create another tunneling connection from here to this IP router into this line, and then the local address of this tunneling connection must be 251, for example. So maybe when we have here 100 IP router, then we have here in the ETS 100 tunneling connection. So to each IP router or to each IP interface we create one tunneling connection. And now when we want to make a download, we select this tunneling connection, the ETS, to our IP router, and then we make a download to the device 1324, and then we have the download here straight via the tunneling server here into the line. So the telegrams on the IP network goes here straight into our line. We don't have the download here, we don't have it here, we have only the download on our IP network here forwarded straight to our IP router. That's the big advantage. We have no traffic here on our complete IP network. So how to create such a tunneling connection? Let's have here a look at the ETS, our topology. We insert here our IP router, which has the address 130, so he works as a line coupler. And then we can see, for example, additionally the first 5 tunneling connect addresses, like 131 up to 135. So these are the default tunneling connections of the IP router. You can change these tunneling connections. For example, instead of using 131, you can change it into 13251, 252, 53. After you have changed here the tunneling addresses, it is necessary to download the application into the IP router. After the download, we go here in the menu interfaces again. Then we can see here all our IP router with the different addresses 130, 150, 270. Then we select the IP router. We want to create a tunneling connection. Click here on the IP router, on the button select, on the bottom, and then we have here then we can use here this IP router for the tunneling connection. Next step, very important, we have to change here the address, or to check if it's really used. The local address of this interface must be in the line. So we want to have a tunneling connection to the IP router 130, and then the individual address of this tunneling connection must be 13251, for example. Click on the button address free. If it's really free, we can test it, and afterwards the tunneling connection is finished, and we can make a download via this tunneling connection to the line 130. So, and then we do the same steps here to the next IP router, to this IP router, and so on, maybe to all your 100 IP routers you have in your installation. So, and we have to do nearly the same in our visualization system. So when we have here PC with visualization, then we create a tunneling connection to this IP router, to this IP router, and to this IP router. And the same principle, when we have 100 IP router, we have to create 100 tunneling connection here in our visualization system or in our panel. So then it depends on the software of your visualization system. Like for example here, we can set here the parameters for the first tunneling connection, KNXNet IP tunnel. We have to write here the IP address of this IP router, and choose here the correct port 3671 for KNX. And then we have to create another tunnel to another IP router with another IP address, and so on. Good, so far how to create these tunneling and routing connections for downloading or to connect, for example, here visualization system. So how we can have access from outside the building, yes, remote access, maybe via your tablet or via PC for operating the system or see some status messages, or also to make a download. So in principle we have here our PC, our tablet. So we get we have a data connection, or we can have access via Wi-Fi. Maybe from Starbucks coffee or in a hotel, or we are connected direct via network cable, but we get a public address. Like for example here 10.3.12.180. This is our public IP address of our tablet or our PC. So now when we want to have connection to our router at home, for example, or to a customer, then he has also a public IP address, which he gets from his public internet service provider, which is, for example, 91.89.7 something. Now when we want to have access to this router, we need this IP address. But this IP address may be changed every day. It depends on your internet service provider. Then the best solution is to use a fixed IP address, but then you have to pay an annual fee. Or to use a service like DNS, it's also annual fee, but it costs about between $5 and $10 per year. And then you have here still dynamic IP address, but via this service you have every time access to your IP address at home. Or another solution is to use a VPN tunnel, which I think is the best solution. So via VPN tunnel, our complete UDP telegrams we are using here in our KNX world or for downloading are now wrapped into TCP IP telegrams, which are be also acknowledged and repeated, and of course also maybe encrypted. So and then it's guaranteed that these telegrams really goes via the World Wide Web here to our router at home, and then forwarded here into our KNX world. But we cannot guarantee what happens here in the World Wide Web. Via a tunnel, in 99% is possible to have a communication, but maybe then it depends on the country, that maybe there are some ports are blocked or some telegrams are not forwarded. So it is possible to make a download via tunnel, but we cannot guarantee really that it's really possible, maybe from different countries or from different continents, because we don't know what happens here really in the background. So when we want to make a download via the World Wide Web, we have here our public address. We start here on our PC or a tablet, additional software, a software client, for example, for this VPN, for this private network. And then we get here a second local IP address, like we are at home with our laptop. So here we have our additional server VPN, and then he sent to the laptop, to the PC, this local IP address. And then you can operate via the browser all your devices here, maybe your network had set storage, like you're really at home with this PC. And then we start the ATS, we create a new tunneling connection, and then we can make really a download here via this VPN tunnel here to our KNX installation. So here's an example of such a VPN software, like we use it here in Germany. It's from a German company, AVM. So we create here, we install a second software, a remote control software here on the laptop, start the software, build up the connection to the router, maybe to the customer or at home. And then we have created a VPN tunnel, which is really, not difficult to create it. Then we start the ATS, go to the menu communication, but then it can happen that via the VPN tunnel our IP router or the IP interfaces are not displayed here, because it depends on the VPN tunnel. And then we have to create manually here a new tunneling connection. Then the window pops up. We can write here name. We have to choose the correct protocol, like you see it on the next screen. Choose your KNX-Net IP, write here name. And we need here the IP address of our IP router or IP interface where we want to make a download. Choose the correct port for KNX and tick here the NAT mode. And then you click OK, and then we can make a download here via the World Wide Web to a customer or at home, what you want. Good, so far about this VPN tunnel. Some more words a little bit about diagnostic. So we have here several lines. You see here maybe the line 110 and here we have the line 170. We have a sensor here in this line which send the group address 2336. We press here the rocker. When everything is okay, the telegram goes here to the IP router. The IP router looks in the filter table, said, oh, I know this group address. He packed it into a KNX-Net IP protocol with this multicast address and send the telegram here on the IP network to all IP routers. The telegram is also forwarded here to this IP router. At first he looks on the multicast address, yes, it's for me. Then he looks in the filter table, oh, I know this group address, and then he sends the group address here into the line. And then what happens? Our actuator with this group address 2336, here for example, switches off. So what happens when we press here the rocker and here our light is still on or still off? So the actuator is not reacting. What can we do? So we can do some steps. The first one, for example, is here we start our group monitor via the USB interface. We press here the rocker and then we can see yes, there is a telegram or no. So we can check if the sensor sends the correct group address and the correct value on or off. Then we are sure yes, the sensor is okay. So next step, we read out via the ETS. We have some diagnostic tools, for example device info. Then we can read out the filter table of our IP router. So we can see if this group address is really added here to our filter table. And then we get here pop-up window, so yes, the group address is really added. So and then the next step, we take our PC and there are some maybe kind of network sniffers, network monitors are available, which shows here our telegrams on the IP network, all traffic on the IP network. So our network analyzer, so we can go on Google and we can find different of the software tools. So we start this tool, we press here our rocker, then the telegram goes to the IP router. He sends the telegram here into our KNX-Net IP protocol in the IP world. When we can see the telegram, so we can check the multicast address, the group address, and then we are sure, yes, this IP router is okay, he sent the telegram into the world. The next step, we take our laptop, connect it here nearby this IP router, start again our monitor here, press here the rocker, and then we can see the telegram is forwarded through all our IP devices. Maybe we have here some switches or hubs or routers, a lot of network devices, and then we can see, yes, he comes here to this IP switch, or no, maybe here somewhere blocked. Maybe the network administrator has blocked, for example, here the multicast addresses. So, and when we can see here the telegram, then we are sure, yes, really here passes all our network devices. So the next step, we can check here this IP router. So at first we connect the USB interface, and we read out again here the filter table to be sure that this group address is really added to the filter table. And the last step, we start the group monitor, and then we can see here if the IP router forwarded this group address here into the line. So these are some steps you can do. For example, go to Google, you can find some kind of this network analyzer or scanners. This is a screenshot of one, for example. You can see here all IP telegrams on the network. A lot of telegrams, because we have here 100 megabyte speeds and a lot of data. What is possible, for example, to filter this telegrams, and then we can see only KNX IP protocols. Like for example here, when we look on the structure of such a telegram on the IP network, we can see here one column, our source. This is the IP address of our IP router. So he sent the telegram into the IP world. Like for example 192.168.175. This is the IP address of the IP router which sent the telegram. So here we see the destination, which is our KNX multicast address. So we can check, yes, the IP router really sends the telegram via this multicast address into the IP network. Here we see the protocol and our useful data. Inside the useful data, we can see our complete KNX telegram. Like here, it starts with the individual address of the sensor which sent the telegram, 1116. This is the individual address, area, line, device number 16. And here we can see the value 2336. This is the group address. And at the end we see here the value is off, also 0. Then we are sure, yes, this IP router sends the telegram with the correct multicast address and the correct KNX group address and value here into our IPP world. Good. So far, another nice software tool I recommend to have on the laptop is a kind of network scanner. So there are also a lot of network scanner available. So this network scanner, you can maybe here change the range. It depends on your IP network to say, okay, from this range 10 to 1255, he scans your complete network and shows you all IP devices. Here, for example, 11, this is the network router. Axis, for example, with 11, this is a webcam. Here's the printer with 39, the KNX telephone gateway. Here, for example, the IP router, IP interface, the Sonos speaker, Android. Maybe this is a tablet. iMac, this is my iMac PC at home. So this software tool is free of charge. It's a small exe file. Scans the IP network and shows all IP addresses. So sometimes it makes sense because it shows also the KNX IP router and the IP interfaces. And so you can identify devices and you can see the IP addresses of this device. Good. All other informations or needed informations of our IP router, IP interfaces you can find on our website abb.com/knx. Go to the product categories and then click on the menu number 2, System Components and Interfaces, and then you can still find here everything about the new IP router 311 and the IP interface 311. The technical data, product manual, the software, the ETS application, ETS 3, 4 and 5, and of course also the link to the latest IBAS tool, which is also available here on our website. So far our webinar today, IP router, IP interface, part 2. I'm sorry, we need a little bit more than 1 hour, but you can see this is really a very interesting and important topic because so many words, routing, tunneling and so on. I think we are at the end of the webinar. So, hello, Thorsten is back.
Hello.
Some information about the webinars in next year, of course, we will still continue with the webinars in the year 2016. We will still have 10 webinars, maybe every month. So we start on Wednesday, also the same day, Wednesday, the same time, 9 o'clock in the morning, 3 o'clock in the afternoon, European time. With the first webinar on the 27th of January with the topic application fan coil. So some advanced features of the fan coil actuator, the blower fan coil actuator, the valve drives. Only not really on the actuators, also very nice, interesting applications and solutions. I hope you will still attend our webinars next year. You get, of course, invitation emails just in time. So far, I think.
Yeah, okay. I think that's all for today. Thank you for participation. We will see you next year with some hopefully new products, but also some applications like this one here. Thank you for participation. See you next time. Bye-bye. Ciao.